Bismillahirrahmanirrahim. Welcome to this lecture, in which that we are going to speak about the sequences. A sequence, which is written in this form or using the notation bracket a sub n from 1 to infinity, is defined as a function. Now, a sequence, in the first term, we can say it is a function, but with special domain. The domain is a set of positive integers. So we can think about the sequence as a function whose domain is the set of positive integers. So what we are going to have now is not a continuous function. We will have a discrete function. Just point, which is not continuous. So sequence is a function or non-continuous function, or just general, it is a function whose domain is set of the positive integers. And we are going to speak about the infinite sequences. But the infinite sequence, or just a sequence, comes out as list of numbers written in a definite order. We call it infinite sequence. It has infinite number of terms. The first one, a sub 1, we call the first term. A sub 2 is the second term. A sub 3, a sub 4, and a sub n is the nth term, or we call the general form of the nth term. And also this will be considered as the general rule of the sequence. Because we said that it has definite order. Definite order means we have a rule for this sequence in which that we can generate terms. And we are going to use the sequence or the notation for the sequence as bracket A1, A2, A3 up to whatever, because it's infinite. Or we can write it as A sub n or A sub n, and n start from 1 to infinity. Unless otherwise stated, we can assume that n start from 1. Most of the sequences, we are using the start point for n equal to 1, unless it is stated clearly that we are going to start from n equal to 2 or n equal to 3 or n equal to different number from 1. So this is the definition for the sequence. We can focus on two things. It is a function, domain is positive integer, and the number of terms or the general rule for the sequence. So we're going to speak about in this part is how to generate the term of the sequence and how to find the general form of the sequence. For example, let's speak about the sequence. For example, this is 1, 2, 3, 4, infinity. This is a sequence, only positive integers. Another example, 1 over 2, 1 over 4, 1 over 6, 1 over 8. This is a sequence. We can speak about another one. Let's say, for example, 0, 3, 8, and we have 16, 25. This is a sequence. And as we said, for each sequence, we have general formula, A, N. So we need to find the general formula for the nth term, or we can say the rule of the sequence. For doing this, let's have these examples. Suppose that we are given the general form or the rule of the sequence, and we need to list the first 5 terms of the sequence. In the first example, I have a sub n equals n to the power 3 minus 1. This is the general formula for the nth term, a sub n. From this one, I need to, I want to generate the first 5 terms for the sequence. So let's say that if n equal to 1, I'm going to replace n by equal to 1, n equal to 2, n equal to 3, n equal to 4, and n equal to 5. These are the first indices for the first 5 terms. Now, if n equal to 1, let's replace n by 1. So A1 is equal to which is 1 to power 3 minus 1, which is equal to 0. So this is the first term. Second term, A2. I'm going to replace n by 2. It is n to power 3. So I will have 2 to power 3 minus 1. That will give me 8 minus 1 equal to 7. A3. So I'm using now n equal to 3. So replace n by 3. I will have 3 to power 3 minus 1. That is 27 minus 1 is equal to 26. And A sub 4, the fourth term, replace n by 4. I will have 4 to power 3 is 64 minus 1 equal to 63. And for the last one, n equal to 5, that will be A 5 is equal to 5 to power 3 minus 1, it is 125 minus 1 is equal to 124. So these are the first 5 terms for this sequence. 0, 7, 26, 63, and 124. Go for the second sequence. I have A sub n, I'm using down this one. 1 over 3 to power n plus 1 is question number 4. So we have 1 over 3 to power n plus 1. So let's use n equal to 1 for the first one. So A1 is equal to 1 over 3 to power 1 plus 1, which is equal to 1 over 10. A2, 1 over 3 to power 2 plus 1, which is equal to 1 over 10. A3, 1 over 3 to power 3 plus 1, which is equal to 1 over 28. And we use this area. I have A sub 4 is equal to 1 over 3 to power 4 plus 1. That will be 1 over 82. And A5 is equal to 1 over 3 to power 5 plus 1. That will be 1 over 244. So these are the first 5 terms for this sequence. And since n is not mentioned, start from which number? We are assuming that the first value for n equal to 1. For example, number 5. I have 2 to power n plus n, but in this case, we have n start from 2. So we have to be careful about this one. N equal to 2. I have 2 to power n plus n. We have 2 to power n plus n, and n equal to 2 to infinity. So the first term, again, it is the first term, it is A sub 1. But I'm going to start with n equal to 2. When n equal to 2, I will have 2 to power 2 plus 2 is equal to 4 plus 2 is equal to 6. And it starts from n equal to 2, as stated in the definition of the sequence. Now the second term, A2. So my point will be n equal to 2, n equal to 3, n equal to 4, n equal to 5, and n equal to 6. So we are done from the first term. Second term, n equal to 3. So I'm going to replace n by 3. So it is 2 to power 3 plus 3. 8 plus 3 equal to 7. The third term, A sub 3, that will be n equal to 4. So it is 2 to power 4 plus 4, which is equal to 20. And A sub 4 is equal to 2 to power 5 plus 5. That's 32 plus 5 equal to 37. And A sub 5 is equal to 2 to power 6. We add them from this one. Then last one is n equal to 6. 2 to the power 60 plus 6, which is equal to 64 plus 6, which is equal to 70. So these are the first 5 terms for this sequence. They are 6, 11, 20, 37, and 70. Now the other point in this, or the second point in this lecture, is to find the general form of the n. We are given the sequence and we need to find the general form of the nth term. Or I can say, I need to find the rule of the sequence. Let's find the formula for the general term A sub n of the sequence. Now in the first one, I have 1 over 2, 1 over 4, 1 over 6, 1 over 8, and 1 over 10. This is question number 17. 1 over 2, 1 over 4, 1 over 6, 1 over 8, and 1 over 10. Now an for this one, for the numerator, it is fixed. It is 1 for all the terms. So I can think about the numerator as to be 1. For the denominator, I have 2, 4, 6. This is n equal to 1. This is n equal to the second term. This is for n equal to 3. This is n equal to 4, and this is n equal to 5. So we can think about the relation between n equal to 1 and 2, n equal to 2 and 4, n equal to 3 and 6, n equal to 4 and 8, n equal to 5 and 10. The relation between this, the value of n and the denominator, is 2n. The difference. So we can say a sub n equal to 1 over 2n. This is the general formula for the nth term. Next one, number 18. I have 4 minus 1, 1 over 4 minus 16. This means these numbers. I have 4 minus 1, 1 over 4 minus 1 over 16, and 1 over 64. So it seems to be that there is no common relation between these numbers. I have 4 and minus 1 and 1 over 4, 1 over 16, and 64. If we think about the last three terms, only the last three terms, I have 1 over 4 to power 1. This is the first one. Second one, it is minus 1 over 4 to power 2. Third one is 1 over 4 to power 3. So it looks like that we have in the denominator 4 to power n, or a power that has n terms. So 1 over 4, but this is my third term. This is my third term, n equal to 3. This is n equal to 4. This is n equal to 5. But what we have down is n to power 1, n to power, or I'm sorry, n equal to 1, or the power is equal to 1, and 4 to power 2, and 4 to power 3. 3 and 1, 4 will go for 2, 5 will go for 3. So it is n minus 2. We can think about it like n minus 2 for the power of the denominator. So we can think about it is 1 over 4 to power n minus 2, but this will not work for the first two terms. I have 4 and minus 1. Let's think about it. I have a sub n. It looks like to be 1 over 4 to power something there. But the first one is 4, so it is not 1 over 4. Can we make it as 1 over 4? We can do it by taking 4 as a common factor for all the terms. So to make it in this form, I'm going to take 4 as a common factor. You write it as 4, and this, what will we have for this now? If I take 4 for the first one, so this is 1. Second term is minus 1 over 4. Third term will be 1 over 16. Third term will be minus 1 over 64. Fourth term will be 1 over 256. That is 4 multiplied by 1 minus 1 over 4, 1 over 6 minus 1 over 64, and 1 over 256. Again, the first one is not 1 over 4, but we can write it as 4 times 1 over 4 to the power 0. You can do it this way. It is 1 over 4 to the power 0. Second one, minus 1 over 4 to the power 1. Third one is 1 over 4 to the power 2. Next one is minus 1 over 4 to the power 3. And next one is 1 over 4 to the power 4. So it is, we can say, this is 4 multiplied by, it is 1 over 4. And we can see it is 1 over 4. But I need to write the power for this one. For the first one, this is n equal to 1, but I got 0 there. This is n equal to 2, but I got 1 power. So it is 4 to the power n minus 1. We need to find the ratio between 1 and 0, 2 and 1, 3 and 2, 4. This is the first term, and 3, 5 and 4. So it is n minus 1. But we have also another thing. It's negative. You have to think about it. When n is even, I have negative sign. When n is odd, I will have positive sign. This is positive. The first term is positive. Second one is negative, positive, negative, and positive. I will have minus 1 to the power something. I have minus 1. To make it positive, then if it is odd, the power must be even. So it is n plus 1. So we can write it? No. Nice way. I will say a sub n is equal to, it is 4, this one, multiplied by the sequence, or just the general term. It is multiplied by minus 1 to power n plus 1, because if I have odd number, the sign is positive, so this must be even power, multiplied by 1 over 4 to power n minus 1. That is 4 to power n plus 1 times 1 over 4 n minus 1. This is the general form. You can simplify it more to say it is 4 with 4 n minus 1. I can say it is n minus 2. You can do it in that way also. So I can simplify this with 4 there. I will write it as minus 1 to power n plus 1, 1 over 4 to power n minus 2. You can write it in this form. This is the general formula for a sub n for this sequence. Second example, we have also number 19 will be the same idea. We can take multiply the common factor, and then we can write the general form.